I like seeing the little
There we are.
Yeah, that's awesome.
Yeah.
Thank you. Yeah.
So welcome to this session. I will very quickly leave the stage to Steve, which will be talking about the art of crafting resilient APIs. So, Steve, the stage is yours.
Brilliant. Thank you.
I will.
Cool. So if you can put there, awesome. The slides. Okay. Well, hello to everybody. I'm in my very expensive room. No, actually, as you can imagine, it's just a fake, and I'm sitting in a small club cupboard. I'm going to talk to you about designing Java APIs in new ways. So it's a wander through. So let me get ready and we'll get this going. Right. So firstly, who am I? Well, my name is Steve Paul. I'm just joined a company called Hero Devs, and you can see that in the slides. Hero Devs is a company that provides end-of-life support for open source software. So there's a lot to that, and I could have a whole presentation on that, but we're not going to do that. I'm going to take you through about API design, and the reason that I'm doing that is partly to do with security. A lot of this conversation comes from me looking at Java from a different point of view than maybe you are. So I'm looking at initially from a security point of view, but also because I have spent a lot of time working on JVMs. I used to work at IBM and I worked at Red Hat on JVMs. A lot of this about how the JVM works and how Java works and things like that it continues to be a great interest for me. So I put together this presentation, and we're going to talk about Java APIs and the design of them, look at some of the history, and look at what we can do from a modern point of view. There is actually a printed version of this talk, or a version of this talk, which you can get on Java Pro. There's a QR code there if you're interested. In fact, it's in the printed magazine, so you can get a digital version. You can go online and find it. But actually, since Java Pro is back to producing paper, you can actually go and get yourself a paper version, which is awesome. So I'm going to take you through, obviously, some background. Why are we here? What's important? Look at Java from various angles. It's not quite the way you may think, because I'm going to look through a series of almost like different lenses about how you look at Java and Java APIs, and look at how that works and doesn't work, and then start exploring a lot about what we can do with modern things in Java that can give you robust APIs that will survive the future. So we'll look at various angles of these things. And there's even a pop quiz, which I can't ask you to put your hands up, so I will pretend to be you, and we'll have some interesting conversations about the various APIs and about Java itself. So the first thing to take away is a scary thing. Everybody downloads Java from Maven Central. You may go to other repos, but by and large, everything comes down from Maven Central. And everything you download from Maven Central has a major version, minor version, and the little point version, so 3 digits. The theory behind this is that you're following SEMVer, semantic versioning, which means that the little number, that changes when you've made a bug fix. The middle number might change when you've added a new feature, and the large number may change theoretically because you've delivered something significant. And the idea really is that you're trying to signal to your consumers that the small number changes when it's a bug fix, the middle one changes when there's a new feature to kick the tires on, and the big one changes when actually you have to recompile because we may have broken you, we may have changed the design. It turns out that much of that would be lovely. In fact, what we discover from Maven is that pretty much you can't rely on that at all. Pretty much anything that you download, whatever number part of the SEMVer changes, yeah, it may break you or it may not. It is hard to tell. And that's not good. So the first thing you have to understand as we progress this is that the way that we do API design and the way we think about it and the way we declare it actually doesn't work very well. right? So we'll look a little bit about why this happens. But it's important to understand that when you pick stuff from Maven Central, that much as you may have some expectation of what you're going to achieve and what you're going to get in terms of experience of what works and what doesn't work, it's still, unfortunately, not going to be what you expect. And there are reasons for this. Some of them are because people make changes, and we'll look at some of those, that you make a change and you think it's okay in your release code, and then you find your consumers are broken. So there's that, definitely that as an aspect. Then the other thing is that people have made changes they think will be okay, but actually they forgot to signal them. Or people are deliberately breaking things. They move fast and break things, right? So there are reasons that people may do this deliberately, but one of the reasons that happens more than anything is the fact that you get hemmed in. Your API has created a shape that is not good, and you want to evolve it, and you can't evolve it without breaking it, which is, again, not good. So again, we were going to go through this, and we'll look at what we can do to identify some of these and prevent them from happening in the future. Now, before we get there, we have to think about how we interact with APIs. As developers, when we're writing these APIs, and then as developers when we're consuming these APIs, there's more than one thing going on here. So we're going to look at 3 different sections. We're going to look at how you think about APIs from an IDE point of view. We're going to look at it from a runtime point of view and from a compile time point of view. So these are 3 different areas of how we interact with Java code that can have different consequences to how we think about APIs and how we consume them. So let's talk about IDE time, which is where we all have IDEs. Everybody uses IDEs, and things happen in the IDE. The IDE gives you help. So here's some examples. So I have some screenshots here. I created an interface. It's called Tree Streamer. It streams a stream. And of course, it's got the wiggly line underneath. So if you're using IntelliJ, which I think most people probably do, it will tell you that there's something wrong. And the help in this comes up and says your raw use of parameterized class stream. It's going, you need to use generics. You need to specify this because the API itself tells you that that's an option and that's what you should do. So you need to sort of go, well, I need to make this more specific. I need to parameterize it. So one of the things I can do is to put some casting in, right? So look, here's some more code. Build stream. This is all in the IDE. First line, build.stream. And you see the IDE is telling me what it returns, a stream of objects, because I haven't parameterized it. So I can cheat. I can do this mapping thing, and I can say, whenever I'm giving something, return it, cast it to a file. And the IDE, because it understands Java, spots that. And now you can see in the gray box, it says streaming of a type file. So we're done. And then there's the rest of the streaming, filtering, things like that. Okay. So that's cool, right? The IDE tells me that I've got a problem. So I tried to fix it by putting a cast in. But actually, that's not the right way to do it. What generics tells you is just declare these things, right? So what I do is they go, the stream that I'm going to return is of type F in here. It takes the parameter F, right? And then when I instantiate it, I can say F is going to be a file. So my code, which before had build stream returning stream object, can now say returning stream with type file. So that mapping, that casting that I put in, I don't need that, right? Because that was just a hack to try and just get the IDE to be nice, right? So there we go. That solves the problem. I've now used the IDE, it's told me some things, and I fixed them. Did that make any difference? So do generics actually help? From an IDE point of view, as you've seen, it really helps. It helps you think about the API. But is it true? How real is this? So when you look at these markers that the IDE tells you, where it looks at the generic information that's available and prompts you and says you should do this or you should do this, that's great, right? It looks wonderful. But I can put code in like this. So look, let's run through this. I have a method called stream. It returns a stream of type file. And then stuck in there is some horrible code, right? You can see that I've got an unparameterized streamer, and that returns a stream of new hash sets. Nothing to do with files, right? And the IDE is moaning at me, but at runtime, or at compile time, this is perfectly valid because the generics are available to you at IDE time. They're compiled into the class, the information's there, but they're not a runtime thing. You will have heard about erasure and what happens there. And effectively, what that means is that all the information you have about the generic type is good for you at IDE time, certainly makes life a lot easier and safer, but that information disappears. If you look at the green line, it tells you what the method signature is. And that method signature says, takes a Java util stream. There's no mechanism in there that tells you that it's of type file or hash set or whatever. That information is erased. So that means that much as you have a class that you're using generics for, and you're hoping your API users will follow suit, there's absolutely no guarantee that they do or that they have to. So when you build these sorts of classes, these sorts of streams, and you go build stream of file, and filter like that, the fact that the IDE tells you that this will return a stream of type file is interesting, but actually at runtime it's not relevant because it doesn't have to be true. So in fact, that line that I took out where I basically cast things to a file needs to actually exist in some form because I have to have defenses in my stream to make sure that the object type that I think I'm getting is actually the right type that I'm actually getting. And if you don't put those sorts of defensive things in, then objects can get into these systems that you weren't expecting. And of course, usually bad things happen. So generics are a great help for developers, but there's no lasting effect. And that's really important to understand that the API that you present, whether you provide options for other people to consume and it's got generics embedded, the ones that you provide, the ones that you consume, it is important to understand that it's primarily an IDE thing. The compiler can moan at you, but it's not going to stop. Right? It is a developer assistance. It's certainly a fabulous thing to have, use it all the time, but understand what happens after you've compiled the code. So now let's look at compile time versus runtime. Again, when you look at Java, there is a significant difference in some areas between what happens at compile time and what happens at runtime. Because at one level, the compile time is what the compiler says, and then the runtime is what the JVM says, and they are not completely aligned. So in some ways, Java is an artifact of the compiler and less of the runtime. So there are some differences, and those differences can break you if you don't understand that they're going on. So let's do this. Normally, I would ask you all to put your hands up, but I'm going to run through this, and we'll see you go. Every time I've done this thing in real life in front of people, I find that most people actually get reticent about putting their hands up. So that's okay. Now I'm going to see how good you are at understanding about Java. So now we have a complicated setup. So we have the layers here. So we have the JVM at the bottom. We have the user code at the top, which is the V1. We have API version 1, which is the code that represents the API we're going to talk about, and its dependencies. So what happens when your user code, version 1, is compiled against your API version 1 with your dependencies? It's whatever it does. Whatever the behavior is encapsulated and captured in that yellow box. And that's cool. But the question is, what happens if we replace that stack with the next version? So what happens when user code that's compiled to use an API version 1 and dependencies version 1 migrates to using the next version? Doesn't recompile, so it's the same code compiled against version 1, and now we're switching the APIs to version 2. So now we're going to explore what you can change to see what happens. So a few things to think about. So return methods. What happens when you change the return method? You can see the pattern here. The top one is version 1 of the code, and the bottom is version 2 of the code. And it's basically when you change one for the other, what happens? Does it break? Does it not break? Yeah, sorry, it's a bit confusing but let me give you the response. You know that if you change the access of a method from public to private, it's no longer visible, and any code that we're relying on is going to fail. So at runtime, it would certainly fail. And then at compile time, your compiler may get it. If you recompiled your code, you may be fine because you didn't call that method in the first place, and the fact that it's gone invisible is irrelevant. So it's a hard runtime failure if you're calling it. It's a soft compile time failure because it depends, again, if you're calling it. So you get the pattern. The interesting thing is that when you look at these types of changes, what you think you can change and what the runtime would enforce or not is not necessarily what you expect, because the compiler is very good at recompiling and re-understanding. So if you change the return type from int to a double, then the chances are that that runtime, it will definitely fail because the return is part of the signature. So the fact that the return is different, just as far as the runtime is concerned, it's looking for a method that returns an int, it doesn't find it, it's a failure. But from a compile time point of view, it's quite possible that the compiler will be able to finesse it and your code recompiles or your user code recompiles and you don't spot it. But at runtime, it might break. And it's the same across the board. There are ways that you change things that you can get away with. So if you return an integer and then in version 1 and you change it to a number in version 2, you might think that's reasonable because they're in the same hierarchy. Well, again, at runtime, it will fail because it's very specifically looking for a return of type integer, a method with return of integer. But at compile time, it may work depending how you're using the return type. So you can see how this works, right? There are things you can change in the code that the compiler can deal with, but at runtime, things may fail. So that means that when you compile, recompile, and retest, you may be missing out problems that your end user is going to get because of those, because the compiler is being not kind, but is able to actually deal with these things. And it's things like exceptions. Can you change the type of exception that is thrown by a method? Version 1 throws file not found or an IO exception. Version 2 changes it completely ridiculous. What happens? Well, at runtime, nothing happens because the exceptions that are thrown are not part of the method signature. The JVM doesn't care. It's a compile time conversation about what to do with it. At runtime, it doesn't, because the VM doesn't work the way that you might think, it doesn't care. Right? It's only a problem when the exception is thrown. And then what happens is the VM goes looking for somebody to catch the exception, doesn't find the catcher because your end user didn't know there was a new method, a new exception being thrown, and so it fails. But because the exception is not part of the method description, the runtime can deal with it, the compiler can't, because the compiler knows it has to make sure that all caught exceptions are call, or exceptions for catching a call. You get the idea. So again, it's this difference between what the compiler can do and what the runtime does that can bite you. Right? And there's one more. Let's talk about something that a lot of people get caught out on because it's one of those things that you just probably don't think about. So version 1, here we have a class called constants, and it's got a public static final string called myConstant, which says hello world. And then version 2, I've changed the constant value. Other than that, that's the only change. Okay. Given that I've got some user code that is, as you can see at the bottom there, that does system.out.println of constants.myConstant, it's going to print out the value that it finds in myConstant. So the bottom bit there is user code. So what happens? What message comes out? Does this, at runtime, do you get the first one, hello world? Or do you get the second one? Now, given that we've updated the binary from version 1 to version 2, you might expect that you would get the second one, that you would get goodbye world. Okay, but you don't, because there's a little foible in the compiler that primitives and strings in this sort of, whether in static finals, get copied into the user code. So that means that if, as an API designer, you change the value of a static final constant, the only way the user code is going to see the change is if they recompile. So think about that in terms of where you might have switches or any sort of conditional stuff based on the assumption that if that changes, you could deal with it. Or that you're assuming that your users are going to be able to return a string with a certain value because you've given it to them as a constant. If they don't recompile, then you get whatever they compiled against. So, takeaway number 3, compile time and runtime are not the same. The JVM has its specification, the compiler has its specification. There is differences about how they operate. The compiler is very, very good at helping you catch the edges, but it's also very good at keeping you safe. And recompiling your Java code can easily hide some of the runtime failures that your users might experience because they don't recompile. So, okay, so that's part of the story, but there's more to it than that. There's also a design conversation that's going on that's causing us problems. So how do you make your API a little safer? Well, you have to start with where we started. And if you've been following Java since the beginning, like I have, then you will know that there are some design patterns in the Java classes that are not necessarily optimal anymore. And if you look at the Java code, you'll have seen this. AWT, Spring, others, there are other places, and it's not just there. You will see a lot of it older, thinking about how you design APIs. Gives you this thing where you have the idea of having abstract classes, interfaces, and concrete implementations. And the thing about that design pattern was this expectation that as a consumer of the API, you would subclass classes and fill in missing behavior. And so your users were part of the conversation that your API was having. And so it relies on the API users understanding about your code and also about them doing the right thing. If they do the wrong thing, whether it's deliberate or not, then bad things happen. And so you end up with this mesh between your code and your end user's code that can end up with unusual behavior happening because your contract is very messy and the relationship between them isn't as well defined as you might imagine. What we can do is we can do this differently. The tools that we have in New Java allow us to think differently about how to design software, and specifically how to design a Java software. So I need you to take a mental shift. Let's forget about old objects and hierarchies and inheritance and stuff like that. Let's think about what APIs should look like and how we want people to interact with them. So I want you to think about the APIs that you interact with. And the one I'm going to put up here is a dishwasher example. Think about what you want your users to do and what you want them not to do. So if you want to provide a dishwasher or a washing machine or whatever, you don't expect your end users to do anything other than load it up. You certainly don't expect your end user to be part of the process, to be in there when the washing machine is clearing things or doing dishes. You don't want to have unusual elements within that dishwasher. What you want to have happen is you want the end user to tell you what policy your machine, your process should follow. And that's it. Maybe it puts a little tablet in the dishwashing drawer and all that sort of stuff, but it's it. It doesn't get involved. Our old style of doing these things with inheritance and abstract methods, all that stuff, was very much like participation. And though we want people to participate in the API, we don't want them to be part of the process, apart from a very constrained way. We should be able to describe an API that allows the end user to specify a policy, and then we should be allowed the process to continue some involvement, but a controlled involvement, and certainly not allowing the end users to insert anything they want in the dishwasher at any part of the process. So you have policy, what do you want me to do? And then you have process, which is my process, which is about how I operate. Right? They are separate. Now, there's a little extra to this that I look at, which I call configuration. But actually, there's the part of your application that you're going to say is configurable, but it's a one-only configuration. For the life of this application inside this VM, there are some decisions to be made. They're what goes in your config file or your properties or whatever, but they're one-off. They don't change dynamically. So you have those, then you have the policy, and then you have the process. Very clear separation. So you say, here's the policy that you provide. You ask the end user to tell you what they want you to do. You have configuration to give you some basic stuff like where do I get the water from or things like that. And then you have a process. And maybe during the process, you will have one or two things you want the end user to have told you as part of the policy, but that's as far as it goes. So how do we do that? Well, let's look a little bit at how the old way worked so you can see what the problem is. So we have the washing machine interface, and we have an abstract washing machine, and we've got all the user setters and getters, right? And that's how we used to do it. The problem with that approach is that any or all of your API can be replaced. And the fact that you have an abstract washing machine means that somebody else can instantiate it because it's abstract and they can do things, they can replace things. So you can ask them to fill in a method, like this guy, like get softener, and two things happen. One is that they can say no, they can do something completely differently, okay? Or in the next one below, like the wash thing. So do you want your end users to override these things? You may or may not have made these things final, but you've only got to get it wrong once, and then somebody is being part of your process. And that usually ends up with them starting to look at the internals of your class, which is obviously a really bad thing to have happen. They use reflection, they start setting fields, and it's just a nightmare because you let them in. And we don't want that. Right. Yeah, and they can break it, yeah. So for the future, what we're trying to do is think about using the APIs to control how the users participate, not just to say what can they call, right? Being much more controlled and moving away from the old OO and abstract method type approach. So we've got things like sealed classes, which are new, newish anyway. they let you take control. So you can see this example. We have sealed interface at the top called I1, and it has the permits clause, and that says here I'm specifying who I'm allowed to implement this interface. And I can do it with the classes as well. This means I can have an interface that's the definition of my API, and I can create classes that are my classes that implement it, and I control. So I can have the flexibility of the design structures of interfaces and classes for my interface, my control, and there are no weaknesses in this space to allow the end user to implement the interface themselves and present it back as you know, in those sorts of conditions. So it's much more, it's much safer to use these tools to create an API that's your API that's stronger and doesn't allow the end user to get in there and upset it. But if you go a bit further and you start using things like builders and inner classes, you can create APIs for end users that are not interfaces, that are not classes, that are done differently using fluent design patterns that allow you more flexibility in the future, because you can change the way those works, and get you away from this participation requirement from the end user. Right. So I think I've said this. Have I got? Yeah. Sorry. Yeah. So let's move on. Right. So what I do is I still use abstract classes, but because I can control who can implement them, I can have an abstract class which has all the code I want stored in a class file separately. So I don't have to have lots of very large class files. I can have a class file which has got the details I want for this particular policy. I can have my own final class here called my URL policy in this example. And all it does is it instantiates the abstract class. It's the only place that happens. But it's private. Nobody else can create it. It's all in my control. And the detail of what actually happens is a separate class file. So I can edit that without having to have lots of code in one place. So that means using this pattern of having a builder, I'll show you these examples in a second, we'll go a bit further on. But the point is that you start saying final classes, so you can't override it. Your end user can't override it. Private constructors, so they can't instantiate it. And then builders, or maybe a simple constructor if it's very straightforward, to do that. And using builders, you can create quite sophisticated DSLs that let you control the conversation that your end user has with your API. So if you think back to what happens with the old style, you have setters and getters, and then you have maybe an execution type method that says do something. But after that, people could be changing the values of your class. It's a very messy relationship between defining the policy and execution. But by using these sorts of approaches like sealed classes, you can start to take control and you can start to design APIs that are more controllable, but more flexible for you. You're not having to change interfaces. You're actually you have a new type of API. So let me give you some examples. Here I have a class called Navigator Policy Builder. Okay. And what does the builder do? Well, the builder, as you can see, uses the ID, uses Fluent mechanisms, uses generics, returns a Navigator Policy Builder. That class, right, is the builder. And then I have things like rate limiting and default readers. And then I have on match and. So I'm building a Fluent definition of my policy using inner classes. And this is building a policy. I'm saying, tell me what you want my API to do. So here's the policy. This becomes an object. I now have an immutable object, which is a definition of a policy. And then I take that policy object and I push it back in. So now I have another class that's a very sophisticated class, right? But you can see at the top it goes policy. Here's the policy. The way to read this is to understand that what the policy is doing is telling this particular class how to do something. And then information comes back. And so after that, what my builder is doing is collecting from the end user how to interact with it, so that it's going, I'm going to give you data. I'm going to stream data to you. Tell me how you're going to interact with it. So therefore, you have these classes coming in, these ons and consumes. And what's going on here is you've now got a object which you've created with the policy. You'll now have an interaction with the end user which says, what information do you want me to tell you? This is probably more dynamic. That is then streamed. And as you can see, things like the consume pattern is, there's it. There's the user code. It's not anywhere in an object. It's not anywhere in a subclass method class. It's just one line that says, go do this. And when you get these objects, tell me so I can do this piece of code. So however you read it, you can see the consumes in here. It's a complicated setup because I want to show you that you can do sophisticated things. You can see all the different IDE prompts that are telling you the different types of objects that are coming back. And that's all done through subclassing and inner classing. It's fairly straightforward to do. And you end up with a new way of designing APIs. It's still Java, but it's not an interface. It's not a class. It's a conversation. And by doing this judiciously, and by using lambdas for the end user to tell you what you need, then you can keep the separation aware, so that certainly these consumption things are going to be used as part of the process, but they're under your control, and there's no way for this end user to break out of that and try and get at what's going on, because they don't know where this is going to run. It's completely safe, and it's under your control, and you can change this design pattern without changing your API, because it's very easy to trigger off different paths without breaking people. So there we go. There are more things, but that for me is the biggest thing, is to show you just how you can use really simple things like inner classes and sealed interfaces and classes to create the control. But just by thinking differently about how you design APIs and getting away from that whole OO thing and thinking about what you can do differently, you can start to build more evolvable APIs. Because if you carry on using the old stuff, it's going to bite you. Because the way that we think about APIs, the way things that we can do to them. So for instance, here I have point class on the left, right? That's my code. It's got X, get Y. And on the right is my user code, and they've extended it. Okay, and they've added their own methods, and I don't mind. That's not my problem until it is, right? Because the fact that they've added new methods to their object, their subclass of my class, means that they are potential clash points. Because as soon as I decide I want to add one that happens to be the same name, and guess what, get Z would certainly match that, then suddenly I've got the situation where my end user may already have picked a method that I'm suddenly going to force them to implement. So you can bet that their implementation is not going to do anything that I'm expecting. Okay. Right. So you have to understand that the old ways of using Java classes, certainly put final everything. You can always take it off, but adding it afterwards is a real break, right? But everything like that ends up, every time that you let the end user do something on their class, they're taking control of your API, right? Because as soon as you try to add the same thing, you can get breakages, right? And so you have to start thinking about the consequences of your design, and object hierarchy and adding new methods and things. You have to understand when you're doing version 1 what the consequences are to version 2. So conscious that I'm probably running out of time here. So let me talk a little bit else about object hierarchies. So object hierarchies sounded great, and they were fantastic for a long time, but they had downsides. And one of the downsides is that they are fragile, because every object in your hierarchy, every class in your hierarchy, every interface in your hierarchy, they are part of your API. Because you can see in that red box, right? I have all these classes and they're all, I have built a hierarchy here. You can see the code, it's all very silly, but it basically goes, hey, I've got a multiple hierarchy here. But in my code, I can represent the class at the bottom, the child class, in variables of any of the types of the parents or the interfaces. And as soon as that happens, then you're stuck, because if you take one of those out, you could break that code. And if you've got APIs that aren't yours, if you've got APIs from, I don't know, Org Apache or wherever they come from, as part of you're implementing them, or you're subclassing them, they're all part of your APIs as well, and they may not be under your control. So this whole structure we have for building Java APIs that we've inherited over the years just has these intrinsic fragility points, and it's good to avoid them. So what do? Step back, don't go overboard, don't build all these big complicated things. Make sure every class is final, right? Make sure the only people who instantiate it are you, unless you're absolutely certain you'll need to let the customer do it, right? Use static methods and things to do that. Lock things down to start, open them up later. Right. Look very much at using builders as much as you can, because builders give you a new way of defining the API. They're not locking your end user into large amounts of details, because at the end of the day, you're going to provide an interface. Here's an instantiated interface with all the things you need to know, and it's going to be very simple. Use sealed classes as much as you can, right? Really go have a look at them and use them to lock down your interface. Put everything behind them. Start realizing that you can build an interface class relationships that represent what your design is, but without having the risk of having the end users be part of it, which is what we're trying to avoid. So you too can build quite sophisticated DSLs. And though this looks sophisticated and complicated, it's actually pretty straightforward. You can make use of the technologies that you're getting out of Java. You can make use of the IDE prompting that you get to build very sophisticated usages. And if you keep that config policy process thing in your head, you can build things that are very strong, that are going to behave the way you expect. Your end user can't get in there and upset them, because you're managing the very small number of places that are allowed to participate. And you have flexibility to change that in the future without necessarily having to change any actual Java API. Okay. And I would say one other thing really is that we have streaming. Use streaming. Don't create large arrays of things. Use streaming. Streaming allows participation from the end user, whether they are giving you a Lambda that you can put into your own filter, or whether they just consume the data and filter it themselves. Streaming for pretty much everywhere is a major first-class thing to think about. Okay, it means you're in control of providing data. If there's any performance things going on, you can do that without having the end user involved. And if you don't want to do that, you don't need to do caching. You can give that responsibility to the end user to cache the things they want. So you have flexibility. Right. So there we go. Build APIs that are under your control. Look at some of the other cool stuff that's going around. Here's the last slide, almost the last slide I'm going to give you, because there is something else that I would love to talk about in detail. But when I talk about sealed classes, you can add those interfaces, sealed interfaces, to things like records. So look at this. I have a public sealed interface called page config, and it permits page selector and page selector v2. So what's going on? Well, when you've got a method and it takes lots of parameters, it can get really chunky and it gets complicated. You can create a record to replace all those parameters. There's one called page selector here. Records are great because they end up being immutable. They're easy to create. They're very simple, but they're not necessarily that evolvable, because with page selectors, if you want to add more parameters, it changes the class, and so you'd have to have page selector v2. Okay, but if you do that, then the method you pass them in will probably need to have some object or something. But no, because you can use sealed interfaces, you can have records implement that, and then you can have an object like, a method like the bottom one, which says public object get data page config. The page config that you pass in is the interface. It's sealed, so the only records that can be created, the only classes that can be created around that interface are ones you can control, and you can use that. You can use records or anything else. But suddenly, this get data method, which may have been quite complicated with lots of interfaces, lots of parameters, and you know how hard it can be to validate all that, can get very simple, and also is very easy to evolve for the future, because you can just add more and more page selectors, variations that you need under your control. So there we go. What can I say? There's a lot to get in. There's a lot more we could talk about as to the things you could do to a Java API that may be good or bad, but that's another talk. What you need to understand is that you can create APIs and evolve them without relying on the old ways of doing them in Java, using new ways. And actually, they're easy to do. And testing them, testing a V1 versus a V2 at build time, is also actually pretty straightforward to do as well. But again, that's another talk. Cool. I will end there.
Oh, really nice. So we're actually in time, and
Cool.
There were a few questions. I will scroll
Excellent.
back here, and first one is from Vuban.
What do you think about people who call the last Semver digit the shame number? Yeah, well, it's fun, isn't it? Because you certainly see products that there used to be this fad for there being 0.9999999 before anybody ever go 1. What do I think? I agree. If you do it a lot, then it's probably too many fixes and retries. I think it might point at the fact that you need a better testing system. I think the shame is that we tend to not test things as well as we should do.
Do you have any suggestion on frequency, for example, for a library, or experience on that?
Well, sort of, you should be released frequently, but what do you do if you don't change it? I think it's really up to you. I think the important bit isn't, with all these things, isn't the frequency. What's really important is how easy it is to do. I think nowadays, when you're releasing software, it should be a joy. And if every time you release software, you have to go through lots of pain, and you realize that, then I think you end up in these circumstances where we're going, well, we'll just tweak the number, because if we just tweak the number, we won't have to do so much testing. So our CI/CD system, which is really difficult to run, or it takes us 5 years to run tests, we don't have to do that. It's just a bug fix. So I think it's more that I would like to see fixed, rather than any particular, how often do you ship software? Yeah, is that okay. What does it mean when you do that? Yeah.
Okay, let's go. I think there's another question. Down here. Okay, so that's a comment from F. Martin Dev.
Excellent. Yes. So they are fabulous things. Records are great. However, they are fixed. You cannot change them. So, as in, if you add a new parameter, they are a new beast. So if you have foo as a record and then you go and change it to foo as a record with a new parameter, the old one doesn't work. There's no overlap. So you have to be quite clear how you manage that, because otherwise you have an enormous proliferation. So that's why I like the interface with seal classes mechanism, because it allows you to control it. Because the last thing you want to do is have people implementing your interfaces directly. But on the other hand, it allows you to manage the records to your design. Yeah, but records are great. There are some edges, like you can't have your own fields and things. So you have to treat them exactly as they are, which is basically a set of parameters on the constructor, and that's it. But they are pretty awesome, and you can use them in some really cool places. I really like the method thing about using them as replacement to parameters, because you can put validation on records. So you can actually have quite sophisticated logic on a record to make sure everything's valid and encapsulate where the data is, and then you pass it in as on a method call. Here's my record of my data, and then you're not sitting there going, did I get that one? Did I not get that one? That's all encapsulated in the record logic, which I think is really cool too.
Yep, I agree. There's another comment here from Johan. We'll get carrier classes. I'm not sure what is it, but then there's another comment about that, which is agreed. Also still waiting for Project
Valhalla. Yes, the whole point of Valhalla surely is that it doesn't come until the end, because I thought the whole point of Valhalla was that's where you went when you were picked up by the Valkyries. Yeah. The thing is that Java, the Java guys, the guys at Oracle and Sun, have done an enormous service to all of us to keep the language as strong and tight as it is. But what we're realizing, and I'm sure they realize this, and they probably realized this for a long time, is that the design of these things is influenced by history. So you look at the way that things like Java beans and things. Java beans, there were lots of Java beans were influenced by like Visual Age Java and things like that, with these wiring of things, autonomous joining of classes together. And there were these ideas about how these things were going to consume, not just in Java, that meant that people designed things that way. And so what you see is very historical, is you see, as the pressures disappear and the reasons for doing things disappear, they still are embedded in the culture. And I'm really hoping that the recent things we're seeing, I mean, what Steel Class is what, Java 14, so not just the recent, but we're seeing really good ideas on how to create modern applications that are going to stand the test of time, which is certainly what we're going to do for Java.
Nice. Just a clarification from Johan that carrier classes are part of Ember. The Java channel had a video on them yesterday. So
I thought they had something to do with pigeons, but there we go.
They still have people, he says, lomboking all things, even though we have good alternatives.
Yeah, yes. Well, annotations is another API conversation about do it badly and it can bite you. And there are certainly people who think that annotations, certainly who are using them with annotation processes in IDEs or compilers, think that they are, how do I put it, not real, and that they're enforceable. And so that's the way it is. We have some really cool tech, but sometimes it gets abused.
There's another one from Marcos Garcia.
Embedding existing ones as fields in new record types. Oh, I hadn't tried that one. I don't see why not. You'd have a record as a parameter to a record. Yeah, that doesn't sound like it would not work. I haven't tried it.
Yeah,
I can see where that might go. It's the objective is not The objective is to help you manage small pieces of data, not build large data structures. But
So I think for this particular case, I've stumbled upon it in a couple of cases, and the most difficult part is going to be the naming, because you have a record foo, and then you have the field, and then you start calling the the container extended foo, because it has one more parameter, and it has a foo inside, and then the second parameter is now going to be complicated, because it's what is going to be super extended foo.
So there is a naming convention from the annals of time, which I can't remember, where basically you could work out what the thing was because the name told you what the parameters were. Now, what was that called? I can't remember what that was, but it was a Microsoft document, I remember. So it was to do with way back. This is like C, when you're writing things in C. But it was one of those ideas to help you understand. So you just read the method type and it would tell you what the parameters were. But that would be fun.
Yeah. So I have a question about what's your take on classes in internal packages for the maintainability of an API? Something that it kind of is an internal thing, and you want to put it into an internal package, signaling everybody, well, this is internal. I have to do it in this way, but because it has internal in the package name, better you do not touch it, because this can change whenever we want. Is that something that you stumbled upon? Do you have suggestions?
Well, so that's sort of part of the way that this thing I've been explaining works, is that you certainly have to put code somewhere. So you have internal code, you put it in a class, give it whatever name you want. You make it abstract so that it has to be subclassed. And then you put the permits thing so that you can control that. So you can, you go for private constructors. If you look at the examples, what I do is I have an abstract class, and I permit the only person to implement it concretely is another one of my classes, but that's an inner class, and that has a private constructor. So the only person who can construct that class is the outer class. So you have outer class, inner class, which overrides a abstract class. Right? So the abstract class has all the code in it, but it only permits this inner class to instantiate it. The inner class has a private constructor on it, and so the only person who can instantiate it is the outer class. So you have complete control of who does that. So there's absolutely no way because that anybody else can break this, because the permits process is enforced by the runtime.
Yeah, I was talking more about, I will give you maybe one more concrete example about this. Would be, for example, an abstract class and then a concrete class, which, yes, like you said, with the sealed technique, you may not extend, but the concrete class has a method that can be called because it's public or, whatever. Right. So at that point, you can find user code that says, oh, I'm going to get this particular instance, cast it down to the concrete class, and then call that method. The idea, if you do it in this way, well, then it's kind of, you're kind of allowed to do it because the class itself is public, although it's a final one. Yeah. If it is internal, maybe it's one more hint to people that says, oh, you're casting down to an internal class now, beware, because that method is public today, but maybe it was a mistake, was meant to be, private or whatever. And
Well, you could go look at the Java module system, because I think it has some things in there to help you with that. But unfortunately, as far as I can tell, pretty much nobody uses JPMS.
I have a different experience on that. Pretty much everybody's asking for it.
Well, that's cool. That's cool. I mean, it's just been one of those things. Again, the Java team have been putting all this effort into it for years. Security features and stuff like that, and it was like people going, we don't use it. We just use the class path.
No. For Jetty, which is the project that I work on, it was like from day one that Java 9 was out that we've been open an issue and say, oh, please modularize everything because we use Jetty as a library, and we really want to have this in place because we want to use JLink and stuff like that. So we had to do like a lot of work.
That's awesome. You should share that. I mean, not just the fact that it's happening, but talk about your experiences, because it's certainly something where I've talked to developers and it's been, no, we don't do that.
Cool.
Yeah.
All right.
Yeah.
All right.
Yeah.
Well, there are no more questions that I can see, so I think time's up. And thank you again for the great session, Steve.
Thank you.
Enjoy the rest of the conference.
Cool. Thank you. Have a good one.
Thank you. Bye.
Bye.